Good afternoon, everyone, and thank you for being here. Welcome to today's CHASS tutorial. Today we will be hearing from Michelle Voong. Michelle is a BU Spark Data Science Solutions Engineer. She has industry experience building identity solutions, proposal writing, and research experience in social media analysis. She's interested in the application of data science related to social issues and fostering environments that enable students to collaborate and innovate. She earned her Master's of Science in Computer Science and Engineering from the University of Connecticut. Welcome, Michelle, and thank you.
Thank you. Thank you. Excited to be here today. So today's topic is on analyzing text data with topic modeling. I work at BU Spark as their data science solutions engineer, so we see a lot of applications of topic modeling and different use cases. And so this tutorial will mainly be talking about what topic modeling is, and then just a easy getting started guide and what you can do with it. And there'll be a notebook at the end, so if you after this tutorial, if you want to try it out yourself on your own data set, feel free to do so. There will be links. Okay. Yeah, so what is topic modeling? Well, let's say you have just lots of text data. It could be articles, it could be social media posts, it could be anything really in a lot of business applications, maybe reviews of products or whatever. And you want to identify, overarching themes between all those text data. Topic modeling is an easy way to gather insights to do that because manually having to read thousands of Amazon product reviews or articles and then categorizing it takes a lot of time. And also there might be differences between each person. They might have a different idea of what the article or the social media post or whatever is actually talking about. And so I listed some applications here. And there are also applications in biology as well, and gene expression analysis. I'm not a biologist by any means, but I have seen that. And then in some of our Spark projects, we've used topic modeling in categorizing news articles, as well as categorizing bills from the Massachusetts legislature. So those are some applications. And then the output from the topic modeling is basically these groups of keywords that are used to represent a collection, a group of documents. And the documents can be articles, social media posts, reviews, that would be considered a document. And by looking at these different groups of keywords, we can kind of judge what it is about. So this second one might be about space, the first one might be about Christianity or religion, and then the last one might be something about security. But from the output of topic modeling, we get these groups of keywords that are used to represent a theme. And so I've picked a data set that's publicly available online, and here's just a little bit about it. The original data set is about 38,000 rows of CNN articles from 2011 to 2022. The data set creator didn't really provide any more details about the specific dates or how it was collected, which that documentation is a problem in and of itself, but I will work with what I have. And then I randomly sampled the data set for about 45% of the articles, just so that it'd be easily distributable, because the original data set was a little bit too big for that. And I've included a link here for if you want to see more details or actually download the original data set. So here we're just going to import some packages to be able to do some data analysis. And then loading the data set, we can see this is our preview. These are just index columns, so we can ignore that. But here we can just see we have two main columns to work with, which is the text of the actual article and the label. So this label is actually just the news section that it belongs to, or the section of the newspaper it belongs to. And from the documentation that they have, we can match these numbers to actual section names. So 0 is business, 1 is entertainment, 2 is health, 3 is news, 4 is politics, and 5 is sport. So then we just add another column for mapping the label to the name, just so that it's easier to look at later on when we have results. Yeah. And then here, just some quick data analysis to see like what kind of data we have. So, and see like what distribution of the sections that we have. So we can see that it's a majority of news and sport, and there's a little bit of politics. Business and entertainment is like the smallest slice of the articles. Yeah, and then some more data cleaning, just filtering out for any empty text values or empty articles, because that doesn't really add to our analysis and we don't really want to deal with that, so just remove them. And then we have the clean data set. Some more things that we can look into is we can lowercase and remove all the spaces, the leading and ending spaces in the text. And then here we're just removing these keywords that are just appearing quite frequently but don't really add to the text data. So like a lot of the times I noticed in the beginning of the CNN articles, they'll have like CNN parentheses, so just tossing that, and then also story highlights. So just keeping the main text of the article is the goal here. And then lastly, I believe this is just some descriptive statistics about the length of the text that we have. So we can see on average that they're about 5,747 words on average per article, with the min being 35 and the max being over 100,000. So that's a pretty long article there. Yeah, and so then now to get into the topic modeling, the main part of the show, but the data analysis in the first part is important because you want to know what type of data you're working with, and that it's clean and that you can get the type of results that you would want. So BERT topic is a topic modeling technique. It leverages transformers, which are really popular now, with GPT and LLMs and everything. But it uses CTF-IDF, which is just a value to create interpretable topic representation. So CTF-IDF is just a way to weight the different words within a group of documents to see which ones are important, and that will give you your topic representations. There are other methods for topic modeling that are out there, like LDA, which is quite popular, and it's much older than BERT topic, but today we'll just be focusing on BERT topic because it's modular and you can switch out different parts for whatever you want. So I'll show you here. This is the general sequence of steps that you need to take to do topic modeling with BERT topic, but within each of these blocks here, you can swap out for different methods that you want to try or you are familiar with. So yeah, depending on your use case, you might want to use a different clustering technique. Like let's say you know how many topics beforehand that you want to identify. You might want to stick with k-means because then you can easily define the number of clusters. But generally, topic modeling is unsupervised, so you don't have a label for each of the articles in the end. You're just trying to find what themes come out of it. And maybe the default HDB scan might work a little bit better just because you don't know how many topics you want to identify, so you're just doing some analysis there. And also, I'll show you later as well, but it accounts for outliers, so maybe none of the topic representations that it comes up with fits an article, so you'll have a group that doesn't really belong anywhere, so you have to figure out what to do with that. Yeah, so here I'll show you right out of the box, you just really need these few lines to get started in building a topic model with BERT topic without having to do any separate like customization or anything. This is all your article text right here, and then you just can fit the BERT topic into the documents and then get a topic model. And then because I'm not going to run it live, it took quite a while, and that'd be quite boring to watch. But just future note for, if you're trying to do this yourself and you want to test multiple different data sets or whatever, you might want to save your topic model so that you can just load it instead of retraining it every single time. Depending on your compute resources that you have, it might take a while. On my computer, I think it took like 5 to 10 minutes, and so that's just waiting. Yeah, and so after getting the topic model, you can get the topic info. So just right off of training it on the number of articles I had, I got 245 different topics. So this first one here, this -1, as I mentioned before, is our outliers. So they don't really fit any of the topics that were generated. And I think by default, a topic will be created if there are 10 articles that fit or 10 documents that fit that topic. And we can just take a look here of the different keywords for each of the topics. Yeah, so this first one might be about golf. And then, and then within BERT topic, you can easily visualize your different topics and the words. I'm gonna switch over to here because can everyone see that, or is it a little small? But yeah, so for the first 16 topics, we can see which words are most important for each one. So here in topic 6, we see vaccine, COVID, health, 19. So this is maybe about the pandemic. I mean, these articles were from 2011 to 2022, so that would have been the right time. And then here, this topic 10 and 11 maybe are about soccer with the top keywords that are generated here. But yeah, and then going back here, another way to measure how well a topic model has done is just by seeing the topics and their corresponding sizes and how they relate to one another. So we see that some of them are similar as they're stacked on top of each other here. So these might all be kind of about sports. There's different, maybe this one's about tennis and there was one about golf here. And then we can also be able to see each of the documents and their topic assignments. And this probability is how well it fits to that topic. So for clustering, it'll just pick the highest one. And by default, a BERT topic assumes that each document has one topic, as we all know from just reading and different articles, that sometimes that's not always the case. A body of text might have multiple topics. So you can account for that by just changing some parameters and maybe getting the top probabilities for the different clusters. Yeah, and then as you could see before, the outliers, we had about 5,000 of them. So BERT topic also gives you different opportunities to be able to reduce the outliers. You can do it on the fly after the topic representations have been created, as I've shown here, or different ways of just grouping and having minimum and maximum clusters beforehand. And so after reducing all the outliers, they've all just fit into one of the topic representations that have been created before. So we don't have the outlier cluster anymore. And yeah. Are there any questions? Anything? Okay. Yeah, so that was just how you could use BERT topic just right out of the box, but you can, it's pretty modular, so you can try and include different methods if you want to, and so we'll go through that now. So here, just a lot more lines of code, but it's not that scary, I promise. So here I've set the minimum topic size to be 20. So to be able to be a cluster or a topic, you have to have at least 20 articles or 20 documents in that group to be considered as one. And then this has been set to auto, so it helps to reduce the number of topics, because as you saw before, we had about like 200. And we have about 17,000 articles to begin with, so that might be, for your use cases, a good enough number, or it might be too much just because having to compare between like 200 different topics might be a lot. And as we saw from like our distribution before, there was a lot of like news and sports articles, so it might just be getting pretty granular into those two sections. And then this calculate probabilities will give you the probabilities for every single cluster. So you can, if you wanted to include multiple topics, you can just choose like the top 3 probabilities and be able to say that this article is about golf and tennis and the Olympics. I don't know if that's true, but it could be a possibility. Yeah, and so then we see here out of that topic model, we get about 76 topics. Sorry, 75 topics, 76 topics. So that's greatly reduced from the original like 200 on the same set of data. And again, we have the keywords that are associated with each topic here. And we can also see that the number of articles per topic is above the like minimum of 20. And again, we can visualize the topics as well. So here we can see there where the topics, their sizes, and how they relate to one another and how far apart they are.
What happened? So you have overlapping topics as well, right?
Yeah. So those topics might be yeah. So the question was about how there are overlapping clusters. So those topics might be similar to one another.
Gotcha.
Like the example I said, there are a lot of sports articles. So maybe an article about tennis. Sorry for all the sports examples. Tennis or golf. They might have like similar like words or like semantic meaning. So they're on top of one another.
So then how do you deal with them? Do like articles get placed in both those clusters, or is it? Oh, sorry.
Mm-hmm.
So then would articles get placed in both those clusters, meaning that it's like a one-to-many relationship with articles and topics, or is it? Is there like?
Yeah. So as you saw before, so with the calculate probabilities, it's just placed to whatever one has the highest probability, whichever cluster. So does that answer your question? So you'll only
like
get one assignment.
Right?
Yeah.
But then how's the probability like determined to put it? So okay, so they would have like varying matching probabilities, right? Like the higher pool versus like the smaller pool.
Mm-hmm.
Okay, makes sense.
Yep. And then here, there's another one that I didn't show before, but you can visualize them all. Like it's kind of messy, so it's kind of a lot to look at. But you can see like the topics in their documents as well. Yeah, so if you hover, you should be able to see like different example documents of like ones that belong to this group or versus this group. And then you can also click on specific ones and zoom in to be able to look at specific parts of this graph. I think it's like frozen, so I'm unable to do that right now. And then, yeah, again, just looking at the top keywords. This like COVID one is still there. And then here's one maybe about immigration, the royal family, based on these keywords here. Although this is from 2022, so I don't know if the like recent news would be is not included.
Would there be a process to have like one-to-many relationship, article to topics?
Article to topics. Yeah, I guess you could you could you could use like calculate probabilities to get like whatever top 3 or 5 probabilities to try to assign multiple topics to one. Different topic modeling methods will initially just assume that a document has multiple topics, so that is just built in the answer. That's not true for a topic though.
Because like just like high level thinking about it, like if they're like when you have like a Venn diagram of like a larger topic and then like a child topic is like just completely within the boundaries of the parent topic.
Yeah.
Not parent topic, but like the base topic, right?
Yeah.
And if like there's like a child topic, then just by like inheritance, it would have like an association with like the parent topic as well. I don't know. That's just
That could be the case, or it just could be within our data set, like we just have more articles that are about the larger topic.
Oh, I see. So size, so the size of the topic isn't the scope of the topic. It's just the number of articles that fit into that. Okay, makes sense.
Yeah. And then again, yeah, we can see here the documents and the different topic assignments and their scores associated with it. So yeah, this one is just an example I wanted to show. So this document about the Queen was assigned to topic 8, and so you can, it's a lot of text, but it seems to be fitting. And then another example I wanted to show, so this, you can also apply your topic model on unseen articles. So this is just an article I pulled from yesterday from CNN about, I think, electric car profits, Tesla. And then here we can just assign it a topic based on our topic model that we have. And since we set the probability, calculate probabilities to be true, we get the probabilities for like all 76 topics. And then we get this assignment, which is 27. And here we can just get the keywords for that specific one. And we can see these are the words that are associated with topic 27: formula, electric car, racing, driving. So it seems to fit. Yeah, and then, these are just repeat examples. And then just another thing I wanted to touch on is with like LLMs and GPT and everything now, we could take these keywords and prompt GPT to give maybe one word that would define the or represent the topic well, because sometimes just having these multiple keywords isn't super useful. We want like an overarching theme or a phrase that would summarize it. So you could do that either just by using the OpenAI API, or BirdTopic also has its built into their package ways of using it. And here's an example. Oh, no, it's not. Oh, there we go. So of these, so on this side is all the topic representation of like the keywords and the OpenAI output on the right. And you don't have to use OpenAI. You could use whatever open source one is available, or other LLMs as well. But there are costs associated with the APIs. So that is something to think about depending on what your use case is. And then, other variations I want to talk about is guided topic modeling. Maybe you have a set list beforehand of like what topics you believe might be in your data set. So you could start with that. Dynamic topic modeling, in our data set, we didn't have specific timestamps, but if you had a larger time range, maybe like 100 years or something, you could see how one topic representation has changed over time. And like the example that's usually used is the way we talk about cars now, like electric vehicles is a lot different from before, like that wasn't really a thing. And then lastly, there's one to touch upon is online topic modeling. So just updating the topic model as new data comes in. Maybe you have a news feed that just has has new articles coming in like every day. You could use online topic modeling to tweak your topic model as new articles come in and possibly try and identify like new emerging topics, I would assume, yeah. And there are other variations as well that I didn't talk about, but here are just some resources. So this first one is a link to the repo that has the data set and the notebook that I shared today. Since I work at Spark, I will always plug this. This is buspark.io. So if you want other tech resources or other guides on like getting started with like data science, visualization, other tools like that, I would definitely recommend checking buspark.io out. This topic modeling notebook will also be there soon. And then here are just more resources on BERT topic. But that's all I had. I will open the floor to questions if there are any.
Can we go back to the vector slide?
Which vector?
Oh, yeah. The vector graph, the XY axis.
Which one?
The main one. Sorry, the first one you showed.
Which one?
One more up.
This one.
So just to be clear, like this, the spots highlighted represent topics, right, or articles.
They're topics.
They're topics, right? Okay. So then like, and then you show like the vectorization function. So is there a way that you can make these? I guess the question is that can you toggle this so that so that you see a smaller number of topics, but that encompass a larger space on the axis?
Oh, this is just for visualizing your topic model. I think if you want to do that, you'd have to like change the topic representation. So maybe like rerun it again.
Right.
Differently if you maybe had like a set of topics beforehand that you knew you wanted to use.
Yeah, but like in the vectorization function, like the code that you showed, like that generated this.
This.
But then what's the AR?
Oh, this
Yeah,
is
the AR topic model,
yeah.
right? Is there something that we can do over there to alter the size of the like to basically like increase or reduce the area of the highlighted sections?
Yeah, there are a couple of things you can do. You could just increase the topic size. So you just have to have like, instead of 20 articles to make a topic, you have to have like 100.
Oh, gotcha,
right?
okay.
So it would depend on your data set size and
Yeah.
how like big or small you want to set that. If you had like millions of articles, you
Right.
would definitely want to increase that.
Okay, and then the underlying word count would then also increase, right, or decrease?
The underlying.
So like you had.
Do you mean the more keywords?
Yeah, exactly.
Yeah, you could also set that to be, because right now by default you just get 10.
Okay.
But you can increase that to consider more.
So right now 10 similar keywords make one topic.
The top 10, yeah.
Right.
is that.
Okay. And then you can toggle that. Okay.
Yeah.
Gotcha. All right. Yeah. Nice.
Yes, I think.
Thank you so much. I had a question about making the kind of the tokenization process. So I just looking at some of your examples of the topics, some of the words seem to represent the same thing. So take the royal family, for example. You could have Queen Elizabeth, who could be referred to as, Elizabeth, Queen Elizabeth, Liz, Queen Elizabeth II. Is there any way in the like the cleaning step before you do the topic modeling of trying to identify these named entities and maybe kind of merge them together, as opposed to just like tokenizing based on spaces?
Yeah, that's a great question. So other topic modeling techniques, you would have to do some sort of cleaning and stemming and stuff beforehand. With per topic, you could just give it the text that you have, and that's if you have like some noisy data, maybe you have like HTML tags, or like I showed before, like the story highlights in CNN, you would want to remove those. But for your question about how to like reduce multiple words that might mean the same thing, you can do that at the end with the representation, or in the beginning with the representation model that you pick. So I didn't show it here, but there's another one that you could use to just get parts of speech. So maybe you just want nouns. So you could specify that to only include nouns and like verbs or whatever. But there are different, representation models that you can include. If I show the picture here at the end to create like a more diverse topic representation. So you have words that don't all mean the same thing or are quite different. Does that answer your question? Okay.
And then does OpenAI come up with like better summations of the, sorry. And then does OpenAI come up with like better summations of, have you tried the internal BERT thing that comes up with like a clear, concise label for a topic as opposed to BERT? Like,
I think it depends. It also probably depends. I haven't tried. I've tried just prompting like GPT and OpenAI without using what's available in the BERT topic package, and that gave varying results. Sometimes it would make stuff up.
right.
But for this I didn't try. What I didn't try though was giving the keywords and some example documents.
I see,
so you
okay.
could try that as well, maybe, and get better results from
No,
that.
but like the BERT internal thing that like BERT has like a way of like coming up with it. So like, does that rely on like some kind of like LLM, or is that like?
BERT, no. So inside BERT itself, so you can set it to be keywords from the topic representation, or you just manually set it. Like me looking at this list of keywords, maybe this is about space.
But BERT doesn't have like a list of like has like a function built in that can take the list of words and come up with.
Not that I know of.
Okay.
No, it would probably just be prompting an LLM.
Gotcha. Okay.
To do that.
Thanks so much for this. Wanted to follow up on your question. There are all sorts of dictionaries that exist to help with stemming and to avoid the problem of too many phrases in keywords that mean essentially the same thing, eliminating plurals and abbreviations and so on, including junk words. You can get rid of junk words. You didn't have to do that using BERT, which is good, I suppose.
Yeah.
But if you want a really clean topic model, you really would want to do that.
Yeah.
So does BERT support automatic inclusion of those dictionaries into a pipeline for topic modeling?
I'm not sure about including those specific ones, because you can, like you said, you can just feed it your text as is. The only thing I could think of is maybe after getting your topic representations is further like manually looking at it yourself and just trying to figure out what like main label you could give it, or just playing around with these different representation tunings at the end, because you can stack multiple ones on top of each other. So that would be my like solution for that.
Okay. Yeah. Another question, if I may. There's another type of pipeline that's just using generative AI at the moment. It's not using BERT. So you actually ask the Gen AI tool to detect the keywords and then attach frequency information to the keywords. And based on that process, which is an interpretive process, it's quite complicated and takes human beings thousands and thousands of hours. It's very, very fast.
Yeah.
And then you can use intertopic distances between the keywords and frequencies to get the normal thing that you would get, which is a topic model of the sort that you produced. So my question is about the comparative value of using Gen AI from scratch versus using something like BERT to do topic modeling, and then jumping on Gen AI just to save you the problem of interpreting the topics and attaching phrases at the end. Can't we be much more aggressive in our use of generative AI at this point?
Yeah, that is a possibility. I would also say, there are costs associated with like LLMs, and so depending on like your use case or like what you're trying to build at the end, it might be better to use something like this where it's free. Yeah, those would be it. Yeah, I think for the quality, I think in both cases you'd have to like manually like look and check and see to see how well it comes out, because there's not really like it's unsupervised, so you don't really have an evaluation of what is like good or not, just other than like looking through.
So no research on relative quality?
There
Yet.
are methods for evaluating like how well the like groups or clusters are, so like of topics, how diverse they are and how much they differ from another. But for evaluating like new articles in itself, you could try other like few shot or zero shot, possibly by just giving examples. But that's also up to you to trust if that is good enough.
I was wondering how topic modeling might work when you have a bunch of documents that you believe are already related in some way. So, for example, we have this Gen AI project where all the research and articles we found are ostensibly on ChatGPT.
Mm-hmm.
Do you think that BERT topic would do a good job of actually distinguishing those articles enough, given that the high-level topic is supposed to be similar? And we can imagine this if we did it in, say, another field, like our home field of religion or something like that, that would it actually be able to kind of categorize the distinctions in mapping the differences between documents that might otherwise be very similar?
Yeah, that may also be different depending on like what embedding model you choose. But like we saw in the example, I'm sorry, I'm gonna go back to the sports, but there are a lot of like sports articles, and it was able to distinguish between the different like types. Depending on your use case, maybe like that's not, like, we don't need that. But I mean, for the Gen AI project case, I think it would be useful for maybe distinguishing between the different uses of Gen AI in like business, education, and government. Yeah.
I just wanted to ask about dynamic topic modeling, which you mentioned briefly at the end.
Mm-hmm.
Is that something that BERT does? Just that was interesting to me, and where would I start to learn more?
Yeah, that's something that that's a variation of BERT topic, and it is, so the creator of it is very active on like in the community on like and his GitHub, and will answer issues like quite frequently if it comes up. But that's where you could be able to get more information. It's built in, so you'd just be able to use it on top of like whatever BERT topic model that you have. Yeah. Yes.
On the dynamic modelling, when we've done LDA topic modelling in the past, we've created videos in order to show the way a network develops. The topic model changes over time, you know, with 1 year or 5 year slices or something. That sort of visualization is super useful for understanding the development of a field or whatever it is you're talking about. How much of that is automated at the moment inside BERT topic versus do you need to bring in third-party tools to get good visualizations of dynamic topic models?
Yeah, I think you should just be able to use BERT topic, even if it's not built in, it's like own in the dynamic topic modeling in that part of BERT topic. You should just be able to automate creating like these visualizations on how they change over time. So you wouldn't need to bring in like another source.
So you mean you would get 100 or 1,000 different images like that, exactly aligned, so that you could drop them into a video making piece of software?
Yeah. Okay. It might take some time though, depending on your compute resources that you have for like training all the different topic models. Yeah.
Much of the material in these topic models is directly useful for doing semantic network analysis. Mm-hmm. Does BERT drop out a semantic network analysis for you as well, or can it?
I don't believe so.
No. Okay.
No, I think what you would get is just like here and how the documents and topics really relate to another, but that might be a little too messy for your use case. Thank you.